Okay, class, this is section 3.5, constructing parallel lines. From your definitions in chapter 1, you should already have the definition of parallel lines in your notebook. But just in case you've forgotten, parallel lines lie in the same plane and they do not intersect. If they lie in different planes and do not intersect, they are called skew lines. But these are parallel lines that never intersect, lying in the same plane. So there are a couple properties that we want to talk about with parallel lines. And we are going to review slope. The parallel slope property in a coordinate plane, so the x and y axis, two distinct lines are parallel if their slopes are equal or they are both vertical lines. So we need to remember how to find slope. We denote slope with the letter M, and to find slope we take the second y coordinate minus the first y coordinate over the second x coordinate minus the first x coordinates. So let's apply that to a problem and just practice. So if I give you the coordinates 3, 6, and negative 1, 4, and ask you to find the slope between them, we'll call 3x1 and negative 1x2. We'll call 6y1 and 4y2. So we just plug those values into our formula. So that's 4 minus 6 over negative 1 minus 3. So 4 minus 6 is negative 2 over negative 4. So the slope between those 2 points is a half. If we look at what that looks like on our graph, here's the first point. Negative 1, 4 is our second point. So if we just connect those, making a line segment, if I go up 1 and over 2, I get to a point on the line segment. Up 1 over 2. So it's the change in the y-axis over the change in the x-axis. So if I'm looking at this number, that means I move up 1 and I move right 2. And that's how you think about slope. It's the tilt of the line or the line segment that you are looking at. Okay, the perpendicular slope property. In a coordinate plane, two non-vertical lines are perpendicular if and only if their slopes are opposite reciprocals of one another. Please put both these properties into your notes. So perpendicular property. If I tell you the slope of a line segment is a half, that means the line perpendicular to that is the opposite reciprocal, which means negative 2 over 1 or negative 2. So if I go back to the picture that I drew, and I want to draw in a perpendicular line, so the perpendicular slope would be negative 2 over 1. So that means from this point I go down 2, because the negative 2, and right 1. Down 2, right 1. And then this line here would be perpendicular. Now that you know what perpendicular lines are and what they look like, you should be able to see and draw good pictures that show perpendicular slope to a line. So parallel lines have equal slope, perpendicular lines have negative reciprocal slope. Okay, so let's do some practice problems. Consider the points given here. Are the lines AB and CD parallel, perpendicular, or neither? So I need need to decide if their slopes are the same if their slopes are negative reciprocals, or neither. So let's see what we get. So I'm going to find the slope between lines A and B, or points A and B, which will be the slope of line AB. So that means I take y2, which is 8, minus y1, which is negative 6, so I turn that into a plus, minus a negative makes it a plus. And then I take x2, which is 6, minus a negative 15, so I'm going to say plus 15. So the slope here is 14 over 21, which simplifies to a slope of 2/3. Now if I find the slope between CD, I'm going to use these points here for C and D. So that's 10 minus a negative 2 over negative 4 minus 4, which gives me 12 over a negative 8. If I simplify that, I get 3 over a negative 2. So 2/3 and 3 over a negative 2 are negative reciprocals of one another. So then we come to the conclusion that line AB is perpendicular to line CD. And I write it as a statement, geometrical statement telling me that the two lines are perpendicular. The next example I have is a picture of a quadrilateral, a four-sided figure. Find the slope of each side, then determine whether each figure is a trapezoid, a parallelogram, a rectangle, or just an ordinary quadrilateral. Explain how you know. So let's review what those figures are. A trapezoid has one pair of parallel sides. A parallelogram has two pair of parallel sides. A rectangle has two pair of parallel sides and four right angles, which means perpendicular lines. So we're going to compare the slopes. If I have perpendicular slopes, that means I'm going to have a right angle, which means it could be a rectangle. So we need to see if we have four right angles or not. Okay, so to do this, you need to figure out what the coordinate points of all these points are. So I'm going to start with I. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. So I has a coordinate point 7, 3. M has a coordinate point of 10. 1, 2, 3, 4, 5, 6, 7. Over 10 up 7. T has a coordinate point of 2. 1, 2, 3, 4, 5, 6, 7. And then E has a coordinate point of 6, 6, 11. So I have my coordinate points. The first slope I'm going to find is of line segment TE. So that is 11 minus 7 over 6 minus 2. So 11 minus 7 is 4. 6 minus 2 is 4. So I have a slope of 1. on that line segment TE has a slope of 1. So let's do the next slope. Let's do the slope between E and M. So 7 minus 11 over 10 minus 6. So 7 minus 11 is -4. 10 minus 6 is +4. So I have a slope of -1. So what does that tell me happens at vertex E? Hopefully you all can see, because these are negative reciprocal slopes, that at vertex E I have a right angle because of the perpendicular lines. Okay, so let's keep going. So far I have one right angle. So let's find the slope between M and I. Line segment MI, I have 7 minus 3 over 10 minus 7. So my slope is 4/3. And then the slope between I and T. 7 minus 3 again over 2 minus 7. So that is 4 over a -5. So there are no more right angles because I don't have any other perpendicular slopes. And I have no slopes that are the same. So it can't be a parallelogram. It's not a trapezoid. It is just going to be an ordinary quadrilateral, but it does contain one right angle. Okay, so you can see there's a lot of work that goes into one problem, trying to figure out what kind of quadrilateral it is. The problems I want you to try before class tomorrow are on page 169 in your textbook, numbers 1 through 4. I will answer any questions that you have in class tomorrow, and I'll see you then.